Good afternoon, guys, and welcome back. In this video, we are going to finish Chapter 3. Now, what you've learned in Chapter 3 so far is measures of central tendency, and actually was probably more review than it was learning in 3.1. That was mean, median, and mode. In 3.2, we discussed standard deviation, measures of spread, and how variable the data set is. Is it widespread, or is it all packed tightly together? Is it consistent or inconsistent? And we measured that with standard deviation, as well as coefficient of variation, and we looked at Chebyshev's theorem. In 3.3, we are going to continue looking at measures of spread, but specifically, we're going to look at measures of spread for data sets that have outliers. So think about this. What causes problems for mean and standard deviation? Well, I hope what's coming to your brain is what I just said, outliers, right? And we talked about this with the housing example. If 6 houses cost $200,000, one house costs $2 million, and you find the mean of the house prices, you're not going to get anywhere near $200,000. It's going to be higher. Why? Because the outlier affects the mean, whereas it does not affect median. Median cares about location of the data value, not the physical value itself. So when we have outliers, we've already established that median is the best measure of central tendency. But how do we look at the spread of data when we have outliers present? Well, we're going to do a couple things. And we're going to start by talking about percentiles. So write this definition down. A percentile is a value where P% of the data fall at or below it. In other words, the 75th percentile means that 75% of people or data, we'll say objects, were at or below the desired score, outcome, whatever you want to phrase it as. Not the desired score, but 75% of objects were at or below the same level as what we're focusing on. Okay? Think about this when in 4th or 5th grade you took a state test, right? You got a little packet in the mail in June and July that said you achieved blah, blah, blah on the state test, which means you're in the 96th percentile in math, the 53rd percent in reading. What does it mean? That means you were at or below, or you were better than 53% of people who took the same English test. You did better than 96% of people who took the same math test, okay? Percentiles are comparative in nature. They do not necessarily look at the physical value, but they compare you to how other people did. So with this in mind, think about this. If you took a 100-point test and got a 97 on it, does that mean you're in the 97th percentile? Well, I hope you would answer no, because what? A 97 out of 100 does not mean you're going to be in the 97th percentile. 97th percentile means you did better than 97% of people. So if everyone else in your class got a 97, you would not have been in the 97th percentile. Again, percentiles is where a value where P% of the data fall at or below it. Well, quartiles are special types of percentiles. Quartiles are special types of percentiles. When you think of the word quartile, the root of the word is quart or 4, right? A quarter is a fourth of a dollar. So quartiles is going to break our data into 4 percentiles, okay? You're going to have Q1, Q2, and Q3, okay? Your first quartile is the 25th percentile, okay? Q2 is the 50th percentile. Q3, the 75th percentile. What you also may know about Q2 or the 50th percentile is that that is the same thing as the median. Okay, so quartiles are special types of percentiles. We will be breaking percentiles into our 4 quartiles. So the question becomes, why are we learning about these? Why are we learning about these different ideas? Well, we're going to do this example in a second, but essentially one way we can represent our data that has outliers and explain the spread of it is by making box and whisker plots out of 5-number summaries. Now you might be thinking, well, what's a 5-number summary? Well, a 5-number summary is where we have 5 numbers that summarize our data. It will include your smallest data value, Q1, the median, also known as Q2, Q3, and your largest data value. Again, it's a way of summarizing the data, and the box and whisker plot will show us the spread of the data. How consistent is the data? Okay? So this is going to be our 5-number summary, and we're going to use it to make a box and whisker plot. So, how are we going to do this? Well, if you look at this example here, I want to make my 5-number summary. So I'm going to have those 5 pieces of data. My smallest data value, which you could tell me right now is 0.16. My largest data value, or stop, we'll do that in a little bit. We'll have our Q1, our median, our Q3, and then our largest data value, which you can already tell off the bat is 1.23. So first things first, let's find the median, which we already know how to do. Well, to find the median, we are simply going to cross off our data values. You'll notice they are already ordered from least to greatest. That's always your first step. Well, once they are ordered least to greatest, we will cross off our data values till we find the middle one. And when I do this, I get a median of 0.5. 0.5. Now the question becomes, how do I find Q1 and Q3? Well, to find Q1 and Q3, you simply will find the median again. The way we find Q1 and Q3 is by finding the median of the first half of the data and the second half of the data. What do I mean? I mean I'm going to find the median again, but I'm going to pretend that 0.5 is the end of my data when finding Q1, or the beginning of my data when I'm finding Q3. But the key here, and I want you to write this down, when we are finding our quartiles, do not include the median in your counting or crossing off. Do not include the median. So what's this practically look like? Well, I want to find Q1, so I want to find the median of the first half of the data set. My median is at 0.5, so I'm not going to include it. So I'm going to start crossing off the data value left of my median. And then I'm just going to keep going. And when I do that, I find that Q1 is 0.33. Do the same thing for the latter half of my data set. And you find that your Q3 is at 1. This is how we find the 5-number summary. It's finding the median of the data set and then finding the median of the first half and the second half to get Q1 and Q3. So we said we use our 5-number summaries to find or to make a box and whisker plot. So we have our 5-number summary. Now how do we make the box and whisker plot? Well, it's pretty simple. You start by drawing a number line. And then this is where your range can change. For me, I'm always going to pick a value below my smallest data value and above my largest data value. So to me, what makes sense is I'll start at 0, and I'm going to work my way up to 1.5, and I'll go up by 0.25. Could you have a different scale? Absolutely. But this is just what makes sense to my brain. As long as your scale is reasonable, I have no problem if you went up by tenths or if you went up by 0.5. Again, you can see I'm going up by 0.25. So we got a first part of our number line. Then what you're going to do is you're going to put little dashes for your smallest data value. So 1 in there. And for your largest data value. Then you will put bigger lines for Q1, Q2, and Q3. Then you will connect Q1 to Q3, making a box. And then you will connect the ends to the box with what we call the whiskers. Okay? This is what's formerly known as a box and whisker plot. Now you might be saying to yourself, well, Mr. Carter, you've said all period or all video, how this tells us the spread of the data. Well, hopefully you can visualize the spread of the data here. Most of the data is packed into the bottom half tightly together, whereas we get more spread out in the latter part of the data. Okay? So our data at the beginning is more tightly packed. This also would help us view an outlier. If I had a piece of data that was significantly larger than the others, that went all the way out here, it'd be easy to visualize the outlier. Again, it's just another way of representing our data and not only looking at the physical data values where the average is, but at the spread of the data. Again, looking at this box, we can see that most of our data is concentrated in the left side, but then our data becomes much more spread out after the median. The final term you need to know is the interquartile range. The interquartile range is simply Q3 minus Q1. And what it does is tell us how much data is in the middle of our data set. Okay? How much is between 0.25 and 0.75. Okay? Or not 0.25 and 0.75, but the 25th and the 75th percentile. How much data is right in the middle, or what's the spread of that, not how much. Okay? So to find it, we're going to do Q3 minus Q1. So I'll do 1 minus 0.67, or 1 minus 0.33, goodness. And I get 0.67. Again, what that does is it tells me, again, I misspoke earlier, not how much data is present, but the spread of the data. What is the width between the first and the third quartile? Okay, so this is what we're going to do in 3.3. We're going to make box and whisker plots out of the 5-number summary, and in that we learn about quartiles. So let's do one more example. And this one, I want you to pause the video and try it on your own. I want you to take a second and use these pieces of data to create a 5-number summary and a box and whisker plot for the data here. Okay, so pause the video and give it an attempt. Then when you're done, check your work with Vine. Well, what you should come up with this data set, I'm not going to write out the work, because you just did that on your own, but you should have come up with a median of 221.5. Your Q1 should have been 182. Q3 should have been 319. Your smallest data value is obviously 111. And your largest data value is 439. Okay, so if we want to make a box and whisker plot out of that, I would start at maybe 100, and I would go up by 50. Again, you could go up by a different scale. That's totally fine. That's a little large here. Gonna go a little bit further. 450. Okay. So then what you're gonna do, where's your smallest data value at? 111. And your Q1 is at 182, so probably right here. Your median is at 221. Right about there. Q3's over at 319. Your largest data value is at 439. So again, similar to our previous data set, you can see that our data is highly concentrated in the beginning and gets much more spread out toward the end. Okay, the final step to all of this, believe it or not, if you want to check your work, there is a way to do this in the calculator, and it's actually very simple. It's going to be almost identical to the process we use to find standard deviation. So if you want to do this, take a second, pause the video, and type all the data in your calculator into a list. Again, click that stat key, click edit, and type all this data into a list. Okay, now that you've done that, what I want you to do is hit stat, tab over to calc, enter first variable stats. Make sure you have the correct list typed in. So calc L2, calc L3, whatever you want to do. Or first variable stats L2, first variable stats L3, whichever list you use. And then finally hit enter. You should get that same screen as when we had X bar, the sum of X, S was at the bottom. I told you to never use the population standard deviation. If you scroll all the way down, you should get a 5-number summary for the data. I would encourage you to try it with this data set. Make sure you know how to do it in the calculator. All right, that wraps up 3.3 and chapter 3 as well. Have a great day.